Question 10 is all about a circle. We've got a k flowing around in the equation for the circle, but we're asked to find in terms of k the coordinates of the centre and the radius. Let's get that out of the way first. So here's the equation of the circle. We've got to group the x and y terms and individually complete the square on them. That's the technique here. Okay, completing the square here, this must be x plus 3k squared. So the multiplication of those brackets, yes, will give us an x squared. Yes, will give us 6kx. The underneaths will give us 6kx. But it will give us surplus of 9k squared. So we have to take that away straight away. Do the same for y squared. So halving this coefficient here, this will be negative k squared. Again, that will give us both the terms we want, but it will give us a surplus k squared. So we must subtract k squared immediately, remembering the plus 7, and this is equal to 0. So given that this is the general equation of a circle, centre A, B, radius R, we've got to match our equation and bash it into this form. So the centre is negative 3k and k as the coordinates of the centre, and the radius is the square root of this. And that's the answer to part A. So in part B, we're now told that a line with equation y is equal to 2x minus 1 intersects the circle at 2 points. Find the range of the possible values of k for this to be true. So to find those 2 points of intersection, we've got to substitute the new equation for y into, well, you can either do it into the completed square version or into the non-completed square. I'm going to do it to the non-completed square version, and I get this. And if I multiply out and group the x squared, x and constant terms out, I get this. And this is a quadratic in x. And if the circle is going to touch at 2 points, the discriminant of this equation will have to be greater than 0. This, of course, is A, this is B, and this is C. Put those values in, and you get this. And if you multiply out and simplify down, you get this, which is now a quadratic in K. And this being a positive coefficient k squared will be a U-shaped curve. And the 2 points we're interested in are the points where the k function curve crosses the axis, because we need this quadratic to be above 0. And it's above 0 from this point upwards and from this point downwards. So if we can find these 2 points, we can then define k as the question requires. For me, I've got to remove this inequality sign before I can factorise, because I can say at the critical points, this inequality can be transformed into an equation. Taking the factor of 4 out, I get k squared minus 14k minus 36 equals 0. Factorising this, I get that k is equal to 7 minus root 85, and k is equal to 7 plus root 85. So therefore I can say that k must be less than 7 minus root 85 or greater than 7 plus root 85. And that's the answer.